Okay, so we are now on the part 2 of this chapter, which is about thermochemistry. Okay, so last time we defined thermodynamics, and the study of thermodynamics in chemical system is called thermochemistry, di ba? So ito yung ating chapter outline. Again, ito lang i-cover natin for this day, the first 3 topics. Then the other topics will be discussed in the asynchronous session. Okay? So let us now talk about introduction to thermodynamics ulit. Okay? So na-define na natin to last time, but again, let's recall. So sabi ko sa inyo, thermodynamics is a study of the energy conversion from of one form to another, no? So, ibig sabihin, if yung energy natin, kunwari, potential energy, naging kinetic energy, yung study ng pag-change ng form of energy is called the thermodynamics, no? And we define energy as the capacity to do work, no? So, ibig sabihin, kapag may work, may gumagalaw, no? So, may flow, may nagbabago, no? Sa energy kapag may work. Okay? For example, this cursor, I think explain it, ito yung example ko last time. This cursor, kapag nag-apply ako ng force dyan, gagalaw yan. So, ibig sabihin, may work and at the same time, may energy. Okay? So, yan. So, ito yung mga, ito yung mga basic form of energy. We have the potential energy, which is the energy at rest. The kinetic energy, which is the energy in motion. And then we have here the vibrational energy of the molecules. When molecules vibrate, they actually produce heat, no? So one way to think of that is yung kamay nyo, so ito yung kamay natin, pagdikitin mo, tapos i-vibrate mo sila, i-rub against each other mo siya. Ano na feel nyo pag vinibrate nyo or ni-rub against each other yung kamay nyo? Umiinat. Okay?
Umiinit.
So yung, yun, umiinat siya, di ba? So yun yung yun yung effect ng vibrational energy. Nagkakaroon ng heat, no? And heat is actually a form of energy. Okay? So from kinetic, nagiging heat siya. Okay? So yun. And we also know that yun nga, we can convert one energy to another according to thermodynamics. For example, we have the solar energy. So yung energy in the form of electromagnetic radiation from the sun that actually allows the solar panels to produce electricity. No? Okay, and it is used to power homes. No? In the Philippines, this is getting relevant na rin recently. I think in Valenzuela, we have solar farm dito sa Valenzuela. I'm not really sure kung saan, pero alam ko meron kami dito. No, sa Lingunan ata, I think. Pero yun. In other cities as well, uso rin yan, no? Pero in other provinces na mahangin, for example, in Rizal, in Ilocos, they use wind, no? Wind energy naman. So they have this uh, giant na ventilador, giant wind turbine that when it spins, it produces electricity. This one is a nuclear energy. So apparently, hindi ito ginagamit sa Philippines, no, because of some concerns which we will address pag nandun na tayo sa chapter na to. Okay? So pero ito ay yung process lang dito is that from the atoms, when atoms break up, no. Okay? Kala nyo kailan nagbe-break up yung atoms din, no. Pag naputol-putol yung atoms into smaller chunks, no, then yun, may energy yun na nire-release. And that energy is actually transferred to water. And the water, pag inabsorb niya yung init ng atom na nagre-react, tumataas temperature nun. So, magbo-boil off yung water. And then yung boiled off water, yung water vapor, it will actually push the turbine which provides power sa nuclear energy. Okay? So, ganun. Yun yung process dito from atoms breaking up to water turning into the vapor phase, and then yung vapor ng water ipupush niya yung turbine, so iikot yung turbine, as a result merong kuryente. Ganun yung nangyayari sa nuclear power plants. Ito naman, this is a matchstick, posporo in Tagalog. Bakit siya posporo? Kasi meron niyang phosphorus. Okay? phosphoro. Okay, so yan. May phosphorus dyan. So, the phosphorus in here, no, when you struck it against a surface, no, na mainit, no, pag in-struck mo yung matchstick sa surface ng umiinit 'yon. So, yung init na 'yon, that is enough, no, to complete this reaction. So, once may enough energy to kickstart the reaction, tuloy-tuloy na, masusunog na yung posporo. Okay? So, ayun yung nangyayari dyan. So, this is from chemical energy to heat and actually light, no? Okay. And then, other form of energy dito is yung particles sa gilid na tutulak niya. So, ibig sabihin, mayroon tayong work. Okay? So, yun lang. And last time, we defined that, in the study of chemical reactions with energy transfer ay tinatawag nating thermochemistry. Okay. So thermochemistry is the study of heat changes in chemical reactions. Okay, so now let's focus on some terminologies that we have to know in studying thermodynamics, no. So sa chemical reactions, no, saan natin ginagawa 'yon? Usually sa beaker, no. So nasa beaker or nasa Erlenmeyer flask, basta nasa lalagyanan yung chemical reactions. For example, tubig, balde ng tubig, doon pwede doon mangyaring chemical reaction. Kasi pag ako naglilinis ng bahay, kunwari kailangan ko gumamit ng muriatic acid, gagawin ko yung tubig, lalagyan ko ng patak-patak ng muriatic acid, no? So may chemical reaction na nangyayari doon, no? Okay? So ganun. So ang tawag natin doon sa part na nilalagay mo yung chemicals mo, we call that the system. Okay? So system is where the reaction will take place, and around it is the surroundings, no? Okay? Ayan. So kunwari gumawa ako ng pinag-react ko yung baking soda pati yung vinegar sa baso. Yung loob ng baso, yun yung system. And yung labas ng baso, yun yung surroundings. Okay? And alam natin that between system and surrounding, meron yang barrier. May takip yan. I mean, may barrier. No? So, ang barrier na yon ay tinatawag nating boundary. Okay? So, ito ay boundary. Yan. So, yan. So, we have three parts, no? So, system, surrounding, boundary. All of this comprises the universe, no? Ito, pag pinagsama-sama mo yan lahat, universe yan. Do you still remember sa algebra? You have this thing, no? Yan. A, B. A and B ay yung universe, di ba? Ginaganon-ganon natin. I forgot the proper notation. Di ba may pag-ganon-ganon yan? Mas may pag-ganon, may ganon. O basta yan. Ganito rin sa thermodynamics, no? Masasabi natin, system plus boundary plus surroundings equal yan sa universe. Okay? Sa buong universe. Ibig sabihin, kunwari naggagawa ko ng chemical reaction sa bote, yung ginagawa sa Mars, surroundings yon. Kasi pag sinabi ng surroundings, it doesn't matter if malapit ka sa system or malayo. Ibig sabihin yung black hole sa labas ng solar system natin, surroundings din yon. Ibig sabihin yung nangyayari sa moon, surroundings din yan. So, pag sinabing surroundings, anything outside the focus. Okay? Anything, even yung Voyager na nasa labas na ng solar system, surrounding siya. Okay? So, ganun. So, in studying thermodynamics, this is important. No? And our focus is always on the system. Okay? So now let's talk about the boundary, no? Because depending on the type of the boundary you will have different types of system. Okay, depende sa uri ng boundary mo, iba-iba yung uri ng system na magagawa mo. Kasi yung surroundings, yun na yun eh, paligid na yun eh. Pero yung system, depende yan kung anong klaseng boundary meron ka. Yung boundary natin, we can classify as this, no? We can have a diathermal boundary, an adiabatic boundary, permeable boundary, and impermeable battery. Battery daw. Boundary. Okay. So let's talk about diathermal. Dia meaning dalawa, no? Dalawang temperatures, no? Ibig sabihin, pwede dito mag-flow yung heat, no? Diathermal, no? So, according to diathermal, the heat can flow, no? So, diathermal boundaries are boundaries where heat can flow. Okay? Bigay tayo example niyan. Kunwari, magkakape ako. Kuha akong baso. Lalagay ako mainit na tubig. Ano mangyayari? Di ba madadama mo yung mainit na tubig sa labas ng baso? Ayun, diathermal yun. Pag nafe-feel nyo, yung init sa loob ng system, pag lumalabas o kaya pumapasok yung init sa system, no? Yung kunwari, yun nga, yung kape, no? Mainit na tubig, lagay mo sa baso, mafe-feel mo mainit sa labas. Ibig sabihin nun, diathermal yon. It allows the heat energy to pass through the barrier, no? So tumatagos yung init sa barrier. Yun yung diathermal. When you say adiabatic, yun yung kabaliktaran. These are boundaries that do not allow heat transfer. Adiabatic yun. Ibig sabihin, mainit man sa loob, pag hinawakan mo sa labas, hindi mo madadama yung init ng nasa loob. Magbigay kayong example ng ganon. Anong bagay sa bahay yung mainit sa loob pero pag hinawakan mo sa labas
Thermos po.
Ayun, thermos. Okay? So, 'di ba sa thermos, maglagay ka ng sobrang init na tubig sa loob, kahit kumukulo yan, okay lang. Pero pag hinawakan mo sa labas, wala kang maramdaman na init, 'di ba? Because yung thermos is a good example of an adiabatic boundary, no? Okay? So adiabatic boundary 'yon. Ano pa bukod sa thermos? Ano pa kaya?
Stainless. Ay, stainless ba yun?
Yung stainless, ano yun diathermal yan. Diba? Stainless na baso. Yung super refreshing pag uminom ka. Eto, nilalagyan to ng ice candy.
Cooler.
Ayun, yung mga cooler o kaya mga styro. Okay, so they are good examples of adiabatic boundary then. Okay. So, yun yung mga adiabatic boundary. As much as possible, they prevent heat from coming in or coming out of the system. No? Coming into the system or out of the system. Pinipigilan nila yon, 'di ba? 'Di ba sa cooler, 'di ba? Yung yelo, lagay mo dun sa loob, di agad yung matutunaw. Kasi nga, yung init ng paligid, hindi siya pumapasok sa loob, no? Ibig sabihin, hindi matutunaw yung yelo kasi yung heat from the outside, hindi siya pumapasok sa system, no? Okay? So, yun yung idea kapag adiabatic boundary. Again, diathermal boundaries that allow heat transfer. Example, baso, plastic, basta yung mga pag hinawakan mo, nafe-feel mo yung init, no? But for the adiabatic, ito yung mga boundaries that do not allow heat transfer. For example, yung sa thermos, yung sa coolers, no? Actually, yung styrofoam, in some sense, it could be an adiabatic boundary. Depende kung gaano kakapal yung styrofoam. Okay? So, ganun. 'Di ba mapapansin nyo kapag bumili kayo yung styro na yung kape na tigli 5 piso. Kapag makapal yung styro, hindi mo talaga mafe-feel yung init sa loob, no? So, it could be an adiabatic boundary. Okay? And now, let's talk about the other thing that could pass through, matter. So, when we describe matter that can or cannot pass through the boundary, pwede natin yung tawaging permeable or impermeable. Yung say permeable, pwede pumasok, pwede lumabas. Okay? Pag impermeable, bawal pumasok, bawal din lumabas. Okay? No, parang lang to, naka-curfew tayo, no? So, pag permeable, the matter can pass through. Kapag impermeable, the matter cannot pass through. Kuha tayong example ng permeable membrane. Permeable boundary. O kunwari, yung baso mo, hindi mo nilagyan ng takip, edi ano yun? Permeable boundary yun, no? Walang takip eh. Ibig sabihin, yung laman ng loob nun, pwede ko dagdagan, pwede ko bawasan, no? Okay? So, yun yung mga permeable boundaries, no? When you can change the amount of matter in the container or in the system. Ayun eh. Pero lagyan mo ng takip yung baso. Magiging ano na yon, impermeable na yon. Kasi hindi na papasok yung particles sa loob ng baso. Either lagyan mo yan ng yung ini-screw na takip. Okay, lagyan mo ng saran wrap, no? Yung plastic film na pinangbabalot sa gulay minsan, saran wrap, no? So ayun, lagay mo yun sa kape mo. Hindi na papasok yung ibang particles sa loob nun, no? So na siya, impermeable. Okay? O kunwari sa thermos, lagyan mo ng takip, edi impermeable na yan. Okay? So ganun lang. So depending on the combination ng diathermal, permeable, impermeable, adiabatic, we can have 3 different types of system. Okay? So if the system is both diathermal and permeable, we will call it an open system. Ibig sabihin, open, pwede talaga pumasok lahat. Pwede rin sila lahat lumabas. Open nga. Okay? Pero, pag ginawa mo yung impermeable, ibig sabihin, tatakpan mo yan. O, nakabaliktaran ng open, edi close. No? Pag tinakpan, close na. Okay? We have an open, closed system. Ayan. Naka-close yung system natin. Ibig sabihin, may takip. No? The matter cannot pass through. Yet, the heat can. No? Kaya ng heat. Okay? Kaya pa rin ng heat naman mag-pass through. For example, di ba, bumili ka ng sa 7-Eleven, yung City Blend nila doon. Okay? Yun yung kape na pag ininom mo, inaantok ka pa rin eh. Ewan ko. Wala na siguro, silbi yung kape sa akin. Okay. Yun, pag bumili ka nun, di ba, tatakpan mo yun, pero mainit pa rin sa labas, di ba? Closed system yun. May takip siya, yes, may takip yun. Pero yung init, lumalabas pa rin. But, if you change the boundary to adiabatic, kunwari, gawin mo makapal na styrofoam yung boundary na yun, tapos may takip pa, naging isolated system yun. When you say isolated system, these are systems that are excluded from the rest of the universe. No? Ibig sabihin, what happens inside stays inside. No? Ibig sabihin nun, kung mainit yung tubig sa loob, wala siyang pake sa labas. Okay? Kasi isolated nga siya. Okay? Parang North Korea na ganun. Isolated sila from the world. No? What happens inside them, hindi natin malalaman. Okay? So, ganun din sa sa mga chemicals. No? So, yun. Example, thermos, yung mainit na tubig that is isolated from everything else. No? Kaya, pag binuksan mo uli yun, mainit pa rin yun. Okay? If you have a very good thermos, yung mainit na tubig could actually last for a week. No? Pero syempre, yung thermos natin, di naman perfect talaga yan na adiabatic system. Kasi binubuksan-buksan nyo yun eh. Okay? Ma-release din yung mga particles and heat over time. Okay? Pero if you have a very good thermos, it can actually hold hot water for weeks. No? I don't know lang if kaya yung months. No? Yun. Hindi naman ako masyado aware with the thermos. Di ako gumagamit yan eh. Kasi ayoko ng kape. Gusto ko malamig na kape. Okay. So other than those those terms, no, ito pa yung ibang mga terms na kailangan natin malaman. Let's talk about this. Thermodynamic processes. So basically yan yung mga changes that our matter could undergo, no. Ito yung mga proseso na dinadaanan ng ating energy. And when talking about thermodynamic processes, maraming uri yan. We have the irreversible process and the reversible process, no. Okay. So itong dalawa, mabilisan lang natin to dadaanan kasi babalikan din natin siya later. When you say irreversible process, these are processes wherein mayroong sudden change, no. binigla mo yung system. Parang kunwari, kunwari ito yung system. So mamaya-maya, ginulat mo, ando na siya sa kabilang side, no? May biglaan, may sudden change, no? Okay? And because of that sudden change in the state of the system, na nagbago kasi siya ng condition agad, hindi na niya mababalikan yung original form niya. Okay? Okay, so hindi na niya mababalikan yung original form niya. For example, yung kahoy, bakliin ko agad, hindi na yung babalik sa original form. Putol na eh, 'di ba? So parang ganun din yung yung energy, no. If you subject it to a sudden change, hindi mo na siya mababalik to its original form. And that's called an irreversible process. Imagine yung kahoy, bakliin ko agad, putol 'yon. Pero when we talk about the reversible process, these are small changes, no. Stepwise, no. Dahan-dahan yung pagbabago, reversible. Okay? So pag reversible changes, that can be returned to the original state now. Kunwari, I have a ruler here. Ngayon ko lang nalaman may ruler pala ako dito. Pagkatingin ko, andun eh. So yan. So kapag binilisan ko to, putol to. Pero if I do small, slow changes, ayun, nabibend ko siya. And nababalik ko siya sa original state, no? So yun yung mga reversible process. Bend ko siya pataas. Bend ko siya pababa. Di ba bumabalik siya sa original form? Yun yung reversible process. Pero kung ito binilisan ko, syempre di ko gagawin. Magkano din to? Pag binilisan ko yung bend niyan, putol to. Irreversible process yun. Iiyak na lang ako kasi sira na. Okay? So, ganun na. So, yan yung mga processes that our energy can go through when under basta yun. Yun yung mga pinagdadaanan ng energy natin. Yun yung processes na pinagdadaanan nila. Reversible and irreversible. I want you to keep that in mind later. Kasi gagamitin natin yan, ha? Ito pa yung iba't ibang uri ng process na sa thermodynamics. No? So we have isothermal, isobaric, isochoric, and adiabatic processes. No? When I say iso, meaning nun, equal. Okay? Or constant. Okay? Kaya nga meron tayong mga ISO certification. Meaning ng ISO kasi ay equal. Ibig sabihin, if you are ISO certified, you have equal traits to the standards, no? Okay? So, yung isa dyan, ISO certified, pero hindi ko sure kung deserved na yung nagparinig eh. Kasi delayed pa rin sweldo namin. Okay. So, hindi yun acceptable. Pero yan. Pag sinabing ISO, yun yung equal siya, no? Equal. So, before and after equal, no? Yung characteristic niya or yung traits. So, pag isothermal, constant yung temperature pag ganun. Isobaric, constant pressure. Baric, no? Kaya nga may barometer. Yung bar doon, ibig sabihin, pressure. Barometer, baric, pressure. Constant yung pressure. Isochoric, ito medyo hindi ito obvious. Pag sinabing choric, volume yun. Okay? So, yun yung mga iso processes. No? Isothermal, constant temperature. Isobaric, constant pressure. Isochoric, constant volume. Let me give you some examples. Kunwari, the transition of water from liquid to gas phase happens at 100 degrees Celsius. Okay? Yung transition ng liquid to gas ay 100 degrees Celsius for water. That is an isothermal process kasi same yung temperature but the particles are undergoing changes. Isothermal process yun pag ganun. Okay? Same temperature but there is something different that happens sa ating system. Pag sinabi namang isobaric, constant pressure. Okay? Kunwari, ano ba mga constant pressure system? Kunwari, mouse ko. Drop ko to dito sa kamay ko. isobaric process yon na isobaric process because the change in the energy of the mass happened at constant pressure. Ano ba yung constant pressure dito? Yung atmospheric pressure. So 180 m pa rin yan kahit ano gawin ko dito. Okay? So isothermal din to kasi mainit sa kwarto ko. Let's say 30 degrees dito. So yan. So, this is isothermal process and isobaric process. Pag isochoric naman, constant volume to. Ang example nito would be kunwari yung um, muriatic acid, pati yung isang batya ng tubig. Hindi, wag naman isang batya. Mga isang tabo ng tubig. 'Di ba pag maglilinis ka ng CR, paghahaluin mo 'yon. Okay. So yung volume na 'yon, constant 'yon. Pero there is something that happens in the system. Umiinit yung system, 'di ba? Pag di nyo alam yan, ibig sabihin hindi kayo naglilinis ng CR. Ganun lang yan. Pero pag naglilinis kayo ng CR, mafe-feel nyo yan. No? Pag inalo nyo yung muriatic sa tubig, yan, umiinit siya. Constant yung volume, pero there is something happening with the energy of the system. Okay? So yan, isochoric process yan. Ganun din kapag paghahaluin mo yung tubig pati sodium hydroxide or lye, pag gagawa ka ng liquid sosa, ako ginagawa ko yung parate kasi barado CR namin always dahil sa mga pusa. So, pag barado na yan, magpe-prepare na ako ng liquid sosa. Meron ako ditong sodium hydroxide. Gahaluin ko lang sila at a constant volume. Then, iinit yung reaction. Sabihin, there is a constant volume process pero the temperature or the heat is transferred. Okay. Then the last one is the adiabatic process. When you say adiabatic process, these are processes where temperature change can happen but there is no heat flow. Is it possible? Yes, no? Pwede magkaroon ng changes in temperature. However, there is no heat flow. Okay? There is no heat flow. Okay? Kasi, ano ba yung temperature? Ano ba yung heat, no? They are not equal talaga, no? So, heat and temperature. They are not really equal. Kasi pag sinabi natin temperature, this is the measure of speed of particles. Okay. So the faster they go, the higher the temperature they possess. If that energy is passed through another body, dun nagkakaroon ng heat flow, no? This is the transferring of energy, heat energy of particles. Okay? So pwedeng ang particles natin super duper bilis pero hindi siya mag-flow from system to the surrounding. Example nun is yung nasa thermos sila. Okay? Ang bibilis ng particles mo. Pero yung energy nila hindi nata-transfer sa labas. So ibig sabihin, there is no heat flow. Mataas lang temperature niya pero walang heat flow. So ganun yung nangyayari sa thermos. There is a temperature inside pero there is no heat flow. Hindi tumatagos yung energy ng loob sa labas. Okay? So, no heat flow yan. Adiabatic process yan. Okay? So, ganun din naman sa cooler, no? So, sa cooler, malamig yung mga molecules. So, they are steady. Malamig yon. So, hindi sila natutunaw agad, no? Kapag pag nasa thermos, let's say, sige, thermos, or kaya nasa cooler sila. Kasi yung init ng surrounding, hindi siya pumapasok sa loob, no? Ibig sabihin, yung energy ng paligid, hindi siya pumapasok sa system para initin yung mga particles. Okay. So, yun yung adiabatic process. Okay. So, pwede talaga magbago yung temperature even without heat flow, no? Pwede yun. Okay. So, pwede yun. Yun lang. Wala na akong masabi, yun lang. Okay, so yun yung mga processes that our particle or our energy could undergo, no? We have reversible, the slow changes, the irreversible, yun yung sudden changes na hindi na siya makakabalik sa original state. You have the isothermal, constant temperature changes, uh, isobaric, constant pressure changes, no? Isochoric, constant volume changes or processes, and we have adiabatic process. Ito yung mga changes in temperature without any heat flow. Okay, so nangyayari to sa sa mga thermos, sa mga cooler. Okay, so yan. Now let's talk about this one, properties of system. In properties of system, pares lang to sa properties of matter, no? Kasi ang system natin yung mga matter, yung mga particles that react to one another. When you say extensive properties, these are properties of matter or the system that depends on the amount of particles present. Ibig sabihin, the more particle is, the greater the extensive property will be. Okay. One example will be this. Okay. I have two containers. Tubig yon. Sino mas marami? A or B? Sino mas marami ang volume? Tubig yung nilagay ko doon. Mas maraming volume yung A. Obvious naman, di ba? Sino mas maraming particles? Sino mas maraming moles? Is it the A or the B? A pa rin. Okay, so A pa rin. Sino mas magulo yung mga particles? Sino mas mataas yung entropy?
Yung B.
Ang sagot doon ay A pa rin. Hindi pa naman natin na-discuss yung entropy. Kaya okay lang naman. Next time, di-discuss natin entropy. Meaning kasi ng entropy, the more the particles are, the the ganun sila kagulo, no? Konyo na naman ako. So the more particles we have, mas magulo, no? Mas malaki yung disorder. Like for example, yung klase. Sa PUP, ang classes usually, pag face-to-face kayo kasi onti lang kayo, no? Which is mababa entropy natin dito. Pero kung wari sa PUP, mayroong klase na umaabot ng 70 people eh. May co-faculty ako na 70 estudyante niya dati. Okay? Nung face-to-face. Okay? So, mas magulo yon, di ba? Kasi alam mo naman, mga estudyante, kung ano-ano pinagagawa sa buhay. Kita mga estudyante, dadaldalan, kokopyahan, iba natutulog, iba nag-ML, no? Natin yung ginagawa nila, di ba? Okay. So, yun, ganun ka gulo kapag sobrang daming particles. Ibig sabihin, yung entropy, extensive property yun, no? The more particles you have, the more, mas magulo sila. Pero, bawasan mo students o sa FEU 40 students kami, no? Mas madali siya i-manage kaysa sa 70, di ba? Okay. Then sa Lasal 20 lang, no? So sa Lasal 20 lang, ay mas madali i-manage 'yon. Then sa subject natin na to, sa section nyo na to, siyam lang tayo. Edi super dali i-manage na ito. Okay? Super dali lang niya i-manage. Okay? So ganun. So yun yung idea. Yung pag mas maraming particles, more entropic, mas magulo. Okay? So we will discuss that more. Okay. How about intensive properties? These properties of matter do not change, no? Whether damihan mo yung particles mo or not. Okay? Isang kilo man yung particle mo or isang kapiranggot lang yung particle mo, ganun pa rin yung kanyang intensive property. For between A and B, let's suppose parehas yan water. Sino sa kanilang dalawa ang mas dense? Between A and B, tubig yung dalawang yan. Sino sa kanila ang mas dense? Sige. Sino ang mas dense? Sino mas mataas density? Paisip kayo, no? Is it A, is it B, or parehas lang?
Pili ko A.
Feeling A? How about the others? Patahimik tayo eh. Sino mas mataas density? A, B, or parehas lang?
A po.
A. Si Marvin, sabi ni Marvin, both, no? So, ang sagot doon ay parehas lang. Parehas lang. Kasi ano ba density ng water? 1. 1 gram per ml yon. Ibig sabihin, ang density ng A ay 1 gram per ml. Ang density ng B, 1 gram per ml. So it doesn't matter whether marami siya or onte. Because intensive properties depend on the identity of the matter, not the quantity. Okay. So damihan mo man yan or bawasan mo man yan, since tubig yan, yung density niya ay yun pa rin. Same pa rin. Okay? So yun yung idea. Okay, so those are, yun yung example ng intensive property of matter. Isang kilo man yan na tubig o isang patak ng tubig yan, ang density nila ay 1 gram per ml pa rin. Ganito, what if ilagay ko silang dalawa sa oven? Lagay ko sa oven at 75 degrees Celsius. Sino ang mas mainit? A, B, or both? Silang dalawa, nilagay ko sa oven. 75 degrees Celsius. Sino mas mainit? Is it the A? Is it the B? Or both lang?
Both.
Both lang. Okay. So, both lang. Kasi iisa lang yung condition nila eh. Okay. So, both lang din. Kung ano temperature nito, ganun din yun. Kasi saan ko ba sila nilagay? Sa 75 degrees Celsius. Before both. At least, di ba? Tawa tuloy. Before both. Amen tayo dyan. Ayan. So, both yan. No? Kasi, nasa isang lalagyanan lang sila eh, di ba? Ibig sabihin, whether ito yan, ganyan karami, or ganito kaunti yan, 75 degrees Celsius pa rin yung dalawang yan. Okay? So, yun yung intensive property of matter. Yung temperature is actually an intensive property. Okay? Yung pressure, ganun din. No? Kunwari, nilagay ko yan sa 180 nalalagyanan. Hindi 180 pa rin yung kanilang pressure. Okay? So, yun yung properties of system. Pag tinanong kayo, always imagine two beakers. No? If their properties depend on their amount, then extensive yon. Ito yon. Pero, if their properties if their properties do not depend on the amount, ito yon, intensive. Okay? So, damihan mo man yan, bawasan mo man yan, since water yan, iisa lang yung density niyan. Okay? Tapos, kung nasa iisang container sila, 75 degrees Celsius, ibig sabihin nun, iisa lang din yung temp nila. Regardless marami yan or onte. Okay? So, yun. And then the last part of the terms, no, terminologies lang tayo muna, is the states of system. So states of system, dalawa yung pinapatukuyan natin. We have a state function and a path function. Okay? So ano to? Pag sinabing state function, its value depends on the difference of the initial and the final state. No? So, ang state function, inaalam niya, ano yung final state, ano yung initial state. Yung difference nun, yun yung value niya. The final state and the initial state. Yung difference nun ay yung yun yung niya, yun yung value ng state function. Okay? So, ganun. Pag sinabing path function naman, it doesn't matter kung saan, yung path function may path, no? Kung saan ka pumunta, doon magdedepende yung value ng path function mo. Bigay ako example para mas clear tayo. Kunwari, I have this, may mountain, ikaw to. Tapos ito yung Bebe Labs mo. A, B. Okay. O, yung distance niyan, kunwari, ikaw, LDR kayo, 10 kilometers. Okay. Tapos may bundok sa gitna nyo. Okay. So, yung displacement, okay, yung displacement, yung difference ng final and initial states, yun yung state function. Yun yung gaano kayo kalayo sa isa't isa. Ano yung path function dyan? O ganito, kunwari pupuntahan mo si letter B. Pwede, umakyat ka ng bundok, tapos bumaba ka. Mas malayo yon. Sabihin natin 15 kilometer. O kaya, ang ginawa mo, etong bundok, inikot-ikot mo pa yan, tapos bumaba ka. Let's say 20 kilometer yon. Okay? So, mapapansin nyo, yung distance ay path function. So, depende sa ginawa mo yung value mo. Pero pag state function, wala siyang pake kung ano ginawa mo. Basta alam niya, ang initial at yung final state ay 10 kilometers. Yun yon. Basta 10 yung difference nun. Pero yung ginawa mo to reach that final point is the path function. Okay? Another example. Kunwari, ako to. Tapos ito yung PUP. Okay. Yan. Flagpole. Okay. Yung distance ko papunta sa PUP, nasa Valenzuela ako. So, 13 kilometers yon pag ginugol mo. So, yun yung displacement, no? Yung from initial to final, 13 kilometers. Mula sa PUP papunta sa bahay ko, vice versa. State function yon. Kasi ang tinitignan niya lang ay yung initial and the final state. Pero kung ako pupunta ng PUP, yung distance traveled ko ay path function. Kasi ano mga pwede ko gawin pag pupunta ako sa PUP? Pwede, ang gawin ko, punta muna akong SM North. Nasa Valenzuela ako. So, dito malapit yung SM North. Tapos punta ako ng Trinoma. Tapos punta akong Cubao. Tapos pagdating ng Cubao, pupunta ako ng Glorieta. Tapos pagdating ng Glorieta, naligaw na ako. Saan ako? Hindi ko na alam. Balik na lang ulit ako Cubao. Tapos yun, diretso PUP na. Ayan. Ang dami kong pwede gawin in between, di ba? So, yun yung distance. Path function yun. Kasi yung distance na travel ko, depende kung ano ginawa ko. Pero yung state function, wala siyang pake. Ano ginawa mo? Mahalaga na achieve mo yung dulo. Okay? Yun yung state function and the path function. Okay? So, ayun. Ano pa yung mga pwede ko gawin? To-travel muna ako. Pwede naman yung isang day, the next day, hindi na ako nag-SM, diretso LRT na ako. Tapos pagdating ng LRT, baba akong recto. Tapos sa recto, nag-isitan muna ako. Jollibee muna. Tapos, kunwari, punta akong FEU kasi may kukunin ako sa FEU. Kunin ko pera ko doon, kunwari. Tapos, pagdating kong FEU, babalik na naman ako sa recto station, then saka ako magpi-PUP. Okay. So, ganun yung distance, no? Ganun yung path function. Depende yung amount niya sa pinaggagawa mo. Okay? Pero pag sinabing state function, it doesn't matter kung ano ginawa mo during the process. Mahalaga nakarating ka dun sa dulo. Is this relatable sa buhay? Yes. Kasi sa buhay natin, ang state function natin ay yung pinanganak ka, tapos mamamatay ka. Okay? Kaya nga sinasabi ko, lahat tayo pinanganak para mamatay. State function yon. Okay? Pero ang path function ay kung ano yung ginawa mo sa buhay mo. Okay? Pwedeng ganito. Ako, nangyari sa buhay ko is 20 years old, nakagraduate ako, nagtrabaho na ako. 23, ayan, nag-aaral na ako uli, master's. O siguro in 30 years old, na ako, namimigay na ako ng pera kasi nanalo na ako ng loto. Tingnan natin kung mangyayari yun. Pagdating ng 40, patay na ako. Kunwari lang. Okay. So, yun yung yun yung ganap sa buhay. Ang state function ng buhay ay beginning and end. Buhay ka, tapos mamamatay ka. Pero yung ginawa mo in between, that is a path function. kunwari, kayo naman, na K-12 kasi kayo, so tumagal yung ending ng education nyo. Kunwari, sabihin natin, state function, mag-enroll ka sa school, as ang ending mo ay makakuha ng college diploma. So, maraming nangyari. So, yung enrollment mo, first year ka niyan. So, yung path function mo doon, pwede, first year, tapos nagka-COVID, tapos nag-working ka muna, nag-work ka, second year, tapos nag-LOA ka, tapos bumalik ka ulit sa third year, so on, tapos nakagraduate ka na. Okay. So, yun yung idea, no? Ang state function, initial to final, no? Enrollment to graduation. Pero yung path function, kung ano yung ginawa mo in between. Okay? And ako, ang sinasabi ko lang sa mga bata, yung path function, subjective yan eh. Depende yan sa anong klaseng environment meron ka, no? So, kung ikaw ay you live a wealthy life, then iba yung path mo compared to others. So, ang gawin natin, wag tayong mag-compare ng path functions natin kasi kanya-kanya tayong trip sa buhay. Kunwari, ako trip ko mag-work agad. Kunwari, trip ko mag-aral na lang muna, mag-scholarship, no? Kanya-kanya yun, no? So, wag natin i-judge yung tao based on their paths, no? I-judge natin sila based on the states, no? Kasi lahat naman tayo ma-achieve yung dulo. Ano yung dulo? Mamamatay tayong lahat. No? So, lahat tayo mapupunta doon, no? So, ibig sabihin, yung ginagawa natin sa kanya-kanyang paths, no? Hayaan nyo na lang, no? So ngayong time ng pandemic, siguro wag na lang muna kayo ma-discourage sa kailangan ko mag-LOA, no? Kailangan ko mag-leave of absence kasi hindi kaya ng family mag-sustain, no? Wag niyo i-down sarili niyo pag ganun. Kasi remember, ang state function naman pag nag-aaral ka is maka-graduate ka pa rin, no? So yun, okay lang na iba-iba yung path function sa buhay. Okay? Kanya-kanyang trip sa buhay yan eh. Kanya-kanyang timeline. Ang mahalaga, ma-reach nating lahat yung timeline, yung ending. Okay? So, ganun yung buhay ngayon ha. Medyo mahirap ang buhay, kaya wag masyado i-down sarili, no? So, kasi, lahat naman tayo makakarating sa dulo. Kanya-kanyang daan lang. Okay? So, yun lang ha. Sa ngayon, wag muna kayo ma-pressure. Bata pa kayo. Actually, mahirap nga na bata ka pa, nag-start ka na magtrabaho. Kasi tignan mo, 23 lang ako. Pagod na ako sa buhay. Feeling ko maaga na ako mamamatay dahil sa stress, no? Ayun, at least kayo, nakapag-prepare pa kayo, no, for work, no? Ako, 20 years old, nagtrabaho agad ako. Pagod. Okay? Pagod agad yun, no? Okay? So, ganun, no? Kanya-kanyang timeline talaga sa buhay. Okay? So, okay lang kahit ma-late ka onte. Basta ang mahalaga, ma-achieve mo yung last point, no? Yun yung goal natin parate. Okay? Ayan, thank you sa pag-attend ng webinar. The joke. Okay. Balik tayo sa topic. Now, let's talk about the first law of thermodynamics. No? Okay. So, in order to understand this, kailangan natin yung mga pinagsasabi kong concept later. Okay? So, now, let's talk about thermodynamics, especially the internal energy. Tapos na tayo sa mga topic kanina. Ayan, balik ulit tayo sa main course natin. When you say internal energy, that is the total energy of a system in equilibrium. Ibig sabihin, itong calculator ko na to, may internal energy to. Okay? May internal energy to. Paano ko mako-compute yung internal energy? Ito yung sabi sa physics. You should add all the kinetic energy and you should add all the potential energy. Pag pinag-add mo yan, you will get delta U. Madali ba yan gawin? Mahirap yan gawin. Kasi, when I say add all the kinetic and the potential energy, you should get the kinetic energy and the potential energy of all the particles here, all the atoms here. Kasi lahat yan, mayroon yung kinetic and potential energy. Even yung electron sa atom, may kinetic energy doon. We know that it revolves around the nucleus, no? Sabihin, ang daming kailangan i-consider, no? To get the internal energy. Kunwari, itong candy na to, dahil dito sa candy na to, sumakit tiyan ko. Max. Kasi kagabi nanonood ako ng movie habang gumagawa ng PowerPoint. Yung Parasite. kagabi ko lang siya napanood, yes. Na, kasi wala akong makita na movie. Sabi ng friend ko meron siya, 'di ba? Pirata. Anyway, so itong candy na to, it actually provides us energy kasi may sugar to. May ano to, yung chemical energy to. Okay. Paano mo malalaman energy nito? I-add mo daw kinetic energy and potential energy nito. Ay sabihin niyan, i-add ko yung mga particles na to. Lahat yan, i-add ko yan. Ilang particles to, di ko alam. Yeah. So parang it doesn't make sense, no, to solve for internal energy because there are so many factors that has to be considered. Sa tao, if you want to get my internal energy, kunin mo potential energy ng lahat ng particles ko, mgh yon. Kasi kinetic energy, computein mo velocity ng mga gumagalaw sa loob ng katawan ko. Ano yung mga gumagalaw sa loob ng katawan ko? Dugo, no? Yung nerve cells, no? Yung firing ng electrons nila. Kaya ako nagsasalita, kaya ako buhay, no? Ano pa mga gumagalaw? Kunwari, yung pagkain, gumagalaw sa sikmura ko. Yung tubig, napupunta sa urinary bladder ko, no? So, lahat yun, you have to compute all of that to get my internal energy. So, ang hirap. Di wag na natin i-discuss, di ba? Kaso hindi may paraan, no? Okay, may paraan to find the internal energy. Take for example itong battery, no? Kaya may picture tayo dito ng battery. So we have battery here and may battery sa loob nun, nasa likod nga lang kaya hindi nyo nakikita. Pero may battery yan, okay? So, if you want to determine the internal energy of the battery, you can use this equation. But, ang hirap Pero according to thermodynamics, I can convert the internal energy to other forms of energy that can be calculated easily. Okay? So one way for me to do that is ito, yung battery, ubusin ko siya, i-coil ko yung wire, i-connect ko yun sa positive and sa negative, tapos i-coil ko siya. Ano mangyayari sa coil? Iinit yun. And actually, you can measure the heat energy produced by this. Gawin mo yon until maubos yung laman ng battery mo. Okay, sabihin, by computing the heat, you now find the internal energy. Okay. So ito yung B, ito yung A. So ginawa ko lahat ng internal energy kinonvert ko as heat or Q. Pwede 'yon. So whatever my Q is, yung Q pwede ma-solve 'yon. Okay? May equations for that, no? Pwede ko malaman yung internal energy ng battery. Kailangan ko lang gawin, ubusin ko lang. Okay? Another way to measure the amount of internal energy sa battery is to use it, no? Use it. Gamitin mo siya. For example, lagay mo siya sa ventilador na 'yan. So when I place my battery in that portable fan, I actually convert the internal energy into two. I have the heat and I have the work. Okay. So, yun yung nangyayari dito. Asan yung heat? Di ba yung makina sa likod niya umiinit? May init yung likod nun Bakit ko alam? Kasi ganyan kami sa PUP. Pag sira ventilador, bumili ka ng ganyan. Meron ako dito. Sa FEU naman, bumili ka ng jacket kasi sobrang lamig. Sa PUP, bumili ka ventilador kasi sobrang init. Di ba? Ang saya. Buti nga hindi ako nagkasakit nun kasi palipat-lipat ako dati face to face. Okay. So, yun yung idea. Ibig sabihin, yung laman ng battery ko, pwede ko siya ubusin completely as heat o kaya pwede ko gamitin yung battery to power up devices. And when I power up my devices, may heat pa rin na malalabas doon. Kasi may makina doon O yung work, paano ko masosolve dito? Pwede mo gawin, find the kinetic energy, o use the proper equations, yan, makukuha mo yung work. Okay? So, ganun. Ibig sabihin, we now have a simpler approach in solving for delta U. Okay? So, we now have a simple approach to solve for the internal energy. Either you convert all of them into heat o kaya in combination of heat and work. Okay? So, hindi mo na kailangan mag-compute ng internal energy as kinetic and potential energy. Ang kailangan mo na lang gawin ay gamitin yon. Gamitin mo kung yung energy na meron ka sa material mo, then yun. Pwede mo makompute yung delta U. Sa pagkain natin, so in food products, no, pag tinignan mo yung likod nun, may nutritional value yon. Paano nila nalaman yung nutritional value? If you ask scientists sa Food and Nutrition Research Institute, FNRI, that is an institute of the OST. Ang ginagawa nila sa FNRI to determine the amount of energy you can get sa food ay sinusunog nila yung pagkain. Literal na sinusunog. And depending on the heat produced by that food, yun yung energy ng food. Okay? Literal na sinusunog yun. Yun yung calorimetry na i-discuss ko next week. Okay? So, ganun. So, ibig sabihin, we now have ways to solve for internal energy. Okay? So, we can use heat and work, which has corresponding equations later on, to measure delta U. Okay? So, yun yung idea. So, hindi na ito yung gagawin natin instead of this one. So, that means our equation can now be rewritten as delta U equals W plus Q. W is work, Q is heat. Now, look at this diagram. From this diagram, is heat and work a state function or path function? Is delta U a state function or a path function? Okay? Sagutin natin yon. Ang internal energy change or delta U, that is a state function. Delta U. Kasi ano lang yan from 100% to 0. Pero yung heat and work, ayun yung mga path function. So, depende kung paano mo ginamit yung value niya. Pwede gamitin mo lahat yan as Q o kaya only portion of that and then yung portion ay W. So, that means ito ay mga path functions. Ito ay state functions. Okay, so yan. So, yung mga state functions, sila yung basta initial to final. Yung, di ba, ganun ginagawa sa battery, basta maubos yan, yun yung energy niya. So, yun yung internal energy, state function. Pero kung paano mo ginamit yung energy niya, that is a path function. Okay, pwede gamitin mo lahat, 100% heat. Kaya, hati-hati na lang, okay? So, ganun. Okay? So, ngayon, ano yung values ng Q with respect to the system? Okay. Ganito. So, inside the circle is your system. If you add heat and work to your system, their value is positive. Okay? Okay. And kapag yung system naglabas ng heat and work, sign nun ay negative. Okay? Ayos yan, surroundings yan. Okay? So, anything na pinapasok mo sa system is positive in value. Anything na nilalabas mo from the system is negative in value. Okay? So, isip tayo. Kunwari, yung system, ininit ko, positive Q yun. Positive Q yun kasi I added energy to the system. The system absorbed energy. Okay? So whenever there is addition of energy to the system, that is positive in value. Think of that as your wallet, no? Bigyan ko kayo 500. Ano mangyayari sa wallet nyo? Plus 500. Okay? So, yung system nyo, plus 500. Kasi yung surroundings, nagbigay ako ng 500 sa system, which is kayo. Bigyan ko kayo 500, di ba? So, positive yun sa inyo. Pero kunwari kayo, bilhin nyo yung bagong skin sa ML gamit yung 500 na binigay ko. Negative yun sa inyo. Kasi kayo yung nagbibigay ng pera sa Moontoon. yung nagbibigay ng pera sa ML para makuha yung skin, di ba? So, lahat ng nilalabas nyong pera, negative. Lahat ng natatanggap nyong pera, positive. In terms of energy, ganun din sa system. So, if the system absorbs energy, it is positive. And if it releases energy, it is negative. Okay? So, yun lang. By the way, itong delta E, dapat delta U yan. Ang delta E kasi ay sa Gen Chem, pag college na, delta U gamit. Pero same lang yan. Okay? So the changes in potential energy tuloy. The changes in internal energy is also the difference of the final energy and the initial energy. But sabi nga natin, mahirap hanapin yung actual value for internal energy. Ang pwede mo lang ma-measure is yung gaano karami yung nagamit mo. So the delta E lang yung pwede mo gamitin. Okay? Okay. So ganun. For example, ito nga, yun sa battery natin. Kunwari, titigan mo lang yung battery mo. Alam mo ba yung energy na nandyan? Hindi. Paano mo malalaman? Gamitin mo. Okay? So that means you cannot solve for the internal energy alone. Rather, you can solve for the amount used, no, to get the internal energy. Okay? So yun yung meaning nun. And then whatever the, whatever the internal energy of the system is, that is transferred to the surroundings. Okay? For example, yung internal energy ng aking battery, nasa na siya? Nagamit ko na. Ako yung surroundings. So, ibig sabihin, yung internal energy niya, na-transfer niya sa akin. Okay? Na-transfer niya sa labas. Okay? So, yun yung ganap dito. So, in equation, that's delta E system equals negative E surroundings. No? Okay. So, actually, dalawang versions yan. If your system released energy, ganito yung equation. And if your system absorbed energy, ganito equation. So, explain natin bakit ganyan yung equation. Negative sa system kasi siya yung maglalabas. Positive sa surrounding kasi siya yung tatanggap. Positive sa system kasi siya yung tatanggap. Negative sa surrounding kasi siya yung magbibigay. Okay? So, kumbaga, magba-back and forth lang yung energy sa kanila. Okay? So, kaya naging ganito yung equation. If you transpose this to the other side, you will get this equation, which is the basis of the first law of thermodynamics. No? Delta U system plus delta U surroundings equals 0. So, that is the basis of the thermodynamics. No? In words, that can be translated as the energy cannot be created nor destroyed. It can only be converted from one form to the other. Yan yung meaning ng equation na yan. Yan yung basis ng first law of thermodynamics. Again, ano uli sabi sa first law of thermodynamics? Energy is neither created nor destroyed. Ano lang daw nangyayari? Energy is converted from one form to another. Okay? So, ganun. Energy is neither created nor destroyed. Energy is converted from one form to the other. Kasi, tignan nyo, yung energy ng system, binigay niya lang sa surrounding. Kung gaano karami binigay niya, edi equal lang yun. Negative lang yun sign. So, pag pinag-add mo yun, 0 yun. Okay? Kunwari, ito, nagbigay ito ng 100 joules. So, negative 100 joule to. Ito, tumanggap ng 100 joule, positive 100 joule. Pag-add mo yon 0. Okay? So, ibig sabihin, conserved ang energy. It is fully transferred to another body. Okay? So, yun yung sinasabi natin na first law of thermodynamics, also known as the law of the conservation of energy. That energy cannot be created nor destroyed. Diba? Ang galing, no? Parang nag-start tayo dito sa battery, tapos biglang nagkaroon na tayo ng law, no? Ganon yung nangyayari sa mga scientists before. Kasi hindi sila distracted, ang dami na lang naiisip, no? So, ganun. Ang amazing, no? Wala kang internet pero nagagawa nila yan. Kasi walang Google eh. So, sila talaga gagawa ng knowledge. Tayo ngayon, we are just benefiting from their efforts, no? From their wisdom. Okay? So, yan lang. Now, let's try to apply the first law of thermodynamics. Delta U equals Q plus W. Calculate the internal energy for a process in which system absorbs 150 joules of heat from the surroundings and does 95 joule of work on the surroundings. Now, basahin maigi. The system absorbs heat. Ibig sabihin yan, Q is positive, no? 150 joule yan. Absorbs siya yung tumatanggap ng heat, no? From the surroundings. And yung work, sabi na doon, does work on the surroundings. Ibig sabihin siya yung gumagawa ng effort sa paligid niya. Ibig sabihin nun, negative yun. What is delta U? So basically, pag-add mo lang, Q plus W, 150 joule minus 95 joule, ang sagot ay 55 joule positive. So that's the delta U. Okay? So ganun lang. Ibig sabihin, we now have a way to solve for the delta U of the system, the internal energy of the system. Alamin mo lang how much heat is produced or consumed, how much work is done, no? Or absorbed, no? Yan. So, ganun lang. Alamin mo lang yung signs nila, alamin mo yung value, pag-add mo yon delta U na agad. Okay? Di ba? Ang galing, no? Paano mo malalaman yung Q? Paano mo malalaman yung W? O mamaya may equations tayong gagamitin, ha? Mamaya, tuturo ko yun. Yung W lang muna kasi yung Q next meeting yan. Okay? So, ayun. Easy lang, na. I want you to try on this. This is open for 1 point plus 1 point. And I want you to determine if the process is endothermic or exothermic. So, that's another 1 point. Ano ba yung endothermic? Ano ba exothermic? Pag sinabing endothermic, that means delta U is, since sasabihin ko na yung sagot, 1 point lang tong recitation natin na to. Sinabing endothermic, endo is positive in delta U. Exo is negative, no? Endo meaning kasi papaloob. The energy is going inside the system. Di ba anything na pumapasok sa system is positive. And anything na lumalabas sa system which is exothermic is negative, no? Now I want you to solve all this. Solve for this. This is open for 1 point. Comment nyo na lang. So antayin ko mag-reply kayo, no? Para may score. Pag-a-add nyo lang yan, but be careful of the sign. Naantok ako. Naantok ako. Di pa kasi ako kumakain eh. Kasi tuloy-tuloy klase ko. Ganun talaga pag nag-work na. Minsan naisipin mo na lang ayaw mo na kumain. Anyway, anong sagot niyo? Si John Crizel, si JC. Yung JC may sagot na siya. Yung iba. Dali, message kayo para may 1 point. Okay, so we now have 4 answers. 5 na. 4, 5. Oh, 2 na lang. Sumagot ulit si Marvin. Ayun din naman yung sagot mo, Marvin. Si Noemi. Nakalimutan niya yung word pala. Okay, so ilan na yung nagsagot? 1, 2, 3, 4, 5, 6, 7. Sir, wala pong negative yung, okay. Hindi, mali na yun. Joke. Wait lang. 1, 2, 3, 4, 5. So, nagsagot si Arabella, si Marvin, Charlene, si Marlet, si JC, si Noemi, and si Jamaica. Baka hindi mo, last time si Jamaica di niya nakita chat, no? Habol mo na lang dito sa chat box. Nasa baba yung chat. Dali lang, no? Anyway, so tuloy na natin. So you will get points, no? And tama kayo. Okay, so madali lang for now. Okay, so Q sabi releases, so that's negative 67.5. And the surroundings do work on the system. Ibig sabihin, sila yung gumawa ng work sa system. Positive yung work, which is 54 kilojoules. I'll just add them, you will get delta U, which is 13.5, negative 13.5 kilojoules. Okay? Ayan. Diba? Ang dali lang na. Ayan, so yan, nakapagsagot naman lahat. Okay, so ibig sabihin yan, 1 point kayo lahat na. Nice. Sana always. Si Arabella. Sino yung absent sa atin ngayon? Si Monica. Ilan ba tayo? 1, 2, 3, 4, 5, 6, 7. 9 tayo eh. So si Arabella, Marvin, si Charlene, si Sembrano, si Noemi, and si Jamaica. Ang absent sa atin ay si Margar. Ay, dito ba si Jara? Si Jara na wala ng internet. Sige, okay lang naman. 1 point lang naman eh. Okay. Next one, diretso na tayo sa main topic, no? Kanina pa ako sabi ng main topic. Ano ba talaga main topic natin? Lahat. Okay. So let's proceed with the next one. 'Di ba sabi ko sa inyo, We now have another way to solve for delta U. Instead of solving for kinetic energy, potential energy, we can just solve for the heat and the work. Okay. What is heat? Heat is the transfer of thermal energy between two bodies. No? Ibig sabihin, there's an energy transfer and as a result, iinit yung bodies natin. Okay? Ang heat ay i-discuss ko na lang sa susunod kasi that's quite a lengthy topic. No? Medyo mahaba yung discussion sa heat. For now, gawin natin yung work. No? So in physics, work is described as the transfer of energy due to existence of unbalanced forces between the system and the surroundings. Ang equation niyan ay W equals F delta X, where F is the force and delta X is the displacement. Okay? But since we are talking about thermodynamics, we should be careful of the sign. No? If the system does the work, then this should be negative now. So, yan. So, yan ha. Ito talaga yung equation nun. But since in thermodynamics, we are focused on, we are sensitive, no? Kung ano yung value, kung positive ba yan or negative, we have to indicate na negative to if the system does the work. Okay? Kasi, bakit yung system fino-focus natin? Kasi nga, dito tayo nakafocus. Yung surroundings, hindi mo focus yan. Okay? So, you are observing the system kasi. So, kasi yung system yung measurable. Yung surroundings, hindi. Kasi when I say surroundings, even yung black hole kasama yan. Meaning kasi ng surroundings, nasa labas ng system. Ibig sabihin yung black hole, yung Andromeda Galaxy, yung supernova sa labas ng universe natin, yung yung friend mo na nasa ibang klase, lahat yan, no, surroundings sila. Hindi mo may measure yung work nun. Ibig sabihin yung system lang yung makukunan mo ng work. Okay? So, siya lang yung matitignan mong may work. Okay? So, yan yung reason bakit we have to assign this. System does the work. Kasi nga, siya yung measurable. Yung surroundings, hindi. Kasama kasi doon lahat ng bagay na nasa labas ng container. Maski ako, no? Maski ako kasama doon. Okay. So, one way to illustrate work is by expansion or compression of gas in a piston. No? Suppose this is a chemical reaction. You have a gas here. Ang mangyayari, kunwari, combustion reaction yan. Ang mangyayari, ano nangyayari sa piston? Umaakyat yung takip nun, di ba? Okay? So, yan. So, umaakyat yung takip niya from initial to the final state, no? If ang movement ng piston ay palabas, no? It means that is expansion. If our work is expansion in process, ibig sabihin yung system yung tumutulak sa takip. So, system yung tumutulak sa takip, no? So, that's W equals negative F delta X. Okay? Now, since alam natin ay gas to, the pressure of the gas, no, which is nasa prob set natin, that is the force over the area. Diba? That's the pressure of the gas. So, if you are solving for the force of the gas, that is F equals A times P. The area, kung nasaan naka-expose yung gas, and the pressure of the gas. Yung pressure, yung force kasi kailangan dito eh. So we need the area times the pressure. Ano yung area na yon? Yun yung area nitong circle na yan. Di ba? Sinolve nyo rin yan sa prob set, no? This is pi r square. Ayan. Pwede mo makuha yung area. Okay. So yan. So let's plug that in. Okay. P A delta X. And nag-substitute tayo. Now, what is A times delta X? What is area times the change in the length? Positive yung change sa X niyan, ha? Kasi ito yung initial. Ito yung final. So, mas malaki yung final kaysa sa initial. So, positive yung delta X natin. For what is area times delta X? Sige, what is that? Area times delta X. That is area times height. Yan ay ano? Yan ay volume. Okay? Sabihin ko na, volume yan. Okay? So, volume yan, no? Kasi may area ka times the height. Diba? Ang area times the height is volume. Okay? So, ibig sabihin, this A delta X is the change in the volume of the gas. Okay? So, this is our equation for the work. W equals negative P delta V. In calculus form, this can be written as dW equals negative P dV. Ayan yung derivation natin for the work if yan ay expansion. Take note of that kasi buburahin ko to. Okay? I need space to write the next one. So kapag expansion, work is negative P delta V. Okay? P is the pressure of the gas. Delta V is the change in the volume of the gas. The calculus form of this equation is this one. Calculus. Ibig sabihin, magka-calculus tayo mamaya. Okay? Madali lang naman. Don't worry. Let us now derive the compression equation. Burahin ko na ha. Compression tayo, compression. So kapag compression, so ito yung initial. Ito yung final. Okay. So yung surroundings yung gumagawa ng work sa system. So that is positive P delta, F delta X. Yung surroundings na yung gumagawa ng ng force, so the P external. Okay? So that's W P external delta X. By the way, yung kanina, yung W negative P delta X, di ba? Delta V, sorry. Yung P na yun ay external lang din. Kwento ko bakit naging P external yan. No? Mamaya ikwento ko kung bakit. So this time, positive yung P external na. Positive yung work natin kasi yung surroundings yung nagtulak sa takip para mag-compress yan. Okay? Ano ngayon yung negative yung bakit siya naging positive, no? Tanungin natin sarili natin, ba't ba positive yan? Balik muna tayo sa umpisa. Sorry. So ito, balik muna tayo ulit sa umpisa. Okay. Yung delta X kasi dito is negative, no? So negative kasi to. Kasi yung length, no? Liliit yung volume ng gas pag tinulak ng paligid. So ibig sabihin our delta X here is negative, no? Negative X. Negative delta X. Negative yung change sa X. Okay. So negative, baliktad. So negative times negative, dun siya magiging positive. Okay? Kaya sinabi natin na positive kapag surroundings yung gumawa sa system. Okay? And we know that the force is the pressure, no? Outside. So this is the P external, A delta X. And we know A delta X is delta V lang din. So that's P external delta V, or in calculus, in calc form, that's dW equals P external dV. Okay, so that is the compression. Side by side ko na lang. So ito yung compression. Ito yung expansion. So kapag expansion, W is negative P external delta B, or dW equals negative P external dV. So, yan yung equations natin. Bakit, sir, naging P external yon? Kasi ganito, di ba? After the expansion or the contraction process, ano mangyayari? The forces will equilibrate, no? After nila magtulakan, hihinto yon kapag equal na yung forces. That means, kung ano yung pressure sa labas, yun din yung pressure sa loob. Ibig sabihin nun, whatever the pressure of the gas is, that is also equal to the pressure of the external gas, no? So, kasi magpapantay din yun, di ba? Kaganon pa ako na. Pwede po bang? Di ba? Pag nagtutulakan yung gases, no? They will come to a point na equal na yung pressures nila. And kung ano yung pressure ng gas sa loob, yun na yung external pressure din, no? So, kaya ginagamit natin is the P external. Okay? So, ayan. Or the final pressure. The final pressure ang ginagamit natin. Kasi yun yung balance na lahat ng forces. Sabihin, hindi nagagalaw yung takip. Okay? So, take note of that equation, pero hindi pa tayo tapos. Hindi pa tayo tapos. So, there are lots of, ingay ko. There are lots of type of expansion. But in our case, isothermal expansion muna, kasi yun lang yung basic. No? Basic lang naman tayo. Okay. So let's talk about isothermal expansion. These are expansion of the gas in constant temperature. No? So maraming uri yan. Irreversible, reversible, irreversible, and reversible. No? Irreversible, reversible compression, and irreversible expansion. Okay? So sabi natin kanina, pag sinabing irreversible, yun yung biglaan. No? Nagulat na lang siya, tapos na yung process. No? Irreversible yun. Okay. So this is the curve. This is the PV curve, no? That's the pressure volume curve. Ganyan talaga itsura niyan. Okay. So suppose this is our initial pressure and the initial volume. Ito yung initial volume. And at this point, we have the pressure 2 and the volume 2. Okay. So, ayan. So, ganito. If you are trying to solve for the work, kapag irreversible process, no? Irreversible process, ibig sabihin biglaan, no? So, ang susundin natin is yung area under the curve, no? Na ito. Okay. So, this area here corresponds to the irreversible work, no? Irreversible expansion na work, no? Kasi nabigla na lang siya, dito siya, nandun na siya. So to get the work, ito na lang yon, itong square na lang yon. Okay. So this portion na lang, no? So what is the area of the circle? Area of the square. So that is negative P external delta V. Or negative P external V2 minus V1. Yan ang equation dyan. Irreversible. Ayan na yan. Save nyo na yan. Irreversible expansion. Nagulat na lang siya. Andito siya. Nandun na siya. So, to get the work, only this square has to be considered. Ito lang yung area. Ito lang yung work. Yung value niyan, yun yung work. Pero, let's talk about this one. Reversible. So, again, we still have P1, V1 here. This is P1. This is V1. And this is P2, B2. Again, yung P2, that's external pressure. P2 is P external. Okay, so ayan. So, pag sinabing reversible, di ba sabi ko kanina, dahan-dahan yan. Okay. Ibig sabihin, hindi siya magugulat. Hindi siya magugulat na, uy, andun na ako. Hindi ganon. Pag reversible expansion, dahan-dahan yan. So, ibig sabihin, madadaanan niya lahat to. Itong curve na yan, madadaanan niya lahat ng process na yan. And in calculus, if we have an infinitesimal changes, pag sa calculus, If you have an infinitesimal changes, that means you are trying to get the area under this curve, no? Lahat yan. Kasi lahat yan madadaanan mo, dahan-dahan ka eh. So, dahan-dahan yan until makapunta doon. So, ibig sabihin, lahat ng area na yan, dadaanan mo. Kasi kapag irreversible, nabigla ka na, andun na lang ikaw, no? Kaya hindi mo na nadaanan yung ibang steps. Kaya ito lang yung area natin. Hindi na niya dinaanan yan, no? Nandun na siya agad. Kaya, ayun. Ito lang yung area natin. Pero, pag sinabing, pag sinabing reversible, dahan-dahan. So, ibig sabihin, lahat yan madadaanan mo. So basically, you are trying to get the area under the curve, no? Sabi ni calculus, kapag infinitesimal change, that can be described by the differential form of the work, no? Okay. Negative P delta B muna. Ayan. Negative P dV. Ito gagamitin mo, calculus form. Basta makita mo yung word na infinitesimal, calculus yan. Okay. The calculus form. Okay. So, yan. So, we are getting the infinitesimal increase in the V. Okay. Dahan-dahan siya. So, area under the curve yan. So, to get the area under the curve, you have to integrate this. May integration. Familiar na ba sa integration? Kung hindi, okay lang. Kasi dadaanan lang naman natin yun. So, if this is from initial to final state, yung dW, initial to final state then, which is just W. Ngayon, how will we integrate this, no? So, ganito. Kapag reversible expansion, there is an assumption. Okay. Ano yung assumption natin? That the gas is ideal. We are assuming that the gas is ideal, meaning it follows the ideal gas equation. Okay, PB equals nRT. To solve for the pressure, that's P equals nRT over V. Plug in natin yung doon. Negative nRT over V dV. Now, yung mole ng gas, constant yon. Yung R, gas constant yon kasi nga constant siya. Temperature is constant kasi isothermal tayo. Ibig sabihin, pwede natin ilabas yung mga terms na yon. Ano lang may iwan sa loob ng integral? Yung volume. Kasi yung volume nagbabago eh. Nagbabago yung volume eh. From here, papunta doon. But everything else is constant. No? So we can write work as the integral from initial to final. Ay, hindi, mali. Labas natin yung mga constant. Negative nRT, integral, initial, final, 1 over V dV. Now, what is the integral of 1 over x dx? Ako nag-advance reading na kayo sa calculus. Kung alam nyo to, ano sagot dito? Integral of 1 over x dx. Kung familiar na. Sagot ay ln x yan. Okay? So that is the natural logarithm of x. But since ang ating variable ay v, okay? So since ang variable ay v natin, 1 over v dv. So that is the ln of the volume. Okay? So this thing here is just the ln of the volume. But you have to evaluate it from initial to final. Meaning non-initial to final, gagawin mo yan na, substitute mo yung F, no? So, ln Vf minus ln Vi. Kung wala pa kayo sa calculus, this must be new, pero madadaanan nyo rin naman to, kaya dinidiscuss ko na ngayon pa lang. Okay? Kasi matuturo din naman to sa inyo. If you're evaluating this integral Fi, so upper minus lower lang yan. So, Vf minus Vi. Applying the rules of logarithm, this can be rewritten as ln Vf over Vi. Yung difference ng logarithm can be shortened to the ln of the fraction. And this is now our equation for the work. The negative nRT ln Vf over Vi. Weird, no? Ang weird, no? Kanina, ganito lang. Tapos biglang, uy, ba't may calculus, no? Kailan ka magka-calculus uli? When you see infinitesimal change or reversible changes. Doon ka gagamit ng calculus kapag may nakita kang reversible processes. No? Kasi slow yung change. Ibig sabihin, dahan-dahan, madadaanan niya lahat yan. Pero kapag irreversible, gugulat siya, uy, andito na ako. Okay, so wala na siyang choice. Hindi na niya nadaanan yung iba. So ito na lang area dito yung kukunin mo. Okay? So yun yung equations, pakisave sa ating puso. Okay? Ngayon, I will ask you, of the two types of work, sino mas malaki yung value? Is it the irreversible or the reversible? Sino mas malaki value? Look at the area under the curve. If you flip ko yung slides para makapag-decide kayo, sino mas malaki? Reversible, irreversible. Sino mas malaki value? Reversible, yes. Reversible yung mas malaki. Kasi tignan mo, hindi lang ito yung sakop niya. Ito din. Okay? So that means that work is really a path function. Ito yung patunay na ang work ay path function. Depende sa proseso yung value mo. Kasi kung reversible yan, ito lang. Pag pag irreversible ka, ayan lang. Pero kapag reversible ka, lahat ng yan. Okay? So ibig sabihin, siya? Path function nga, no? So totoo yung sinabi natin kanina. That work is a path function. Kasi nga, iba-iba yung value niya. Okay? So, iba yung value niya dito sa process na to. Iba rin yung value niya sa process na to. Okay? Ayan. Now, let's talk about compression. Yung compression, dalawang forms din. Irreversible and the reversible. So, kapag compression, we start with a higher pressure, higher volume. So, ito yung P1, V1 natin. And this is the lower volume, the P2 or the P external and the V2. Nabaliko na yung aking line. Okay, so this is P2, P1, this is V2, this is V1. Okay, so irreversible compression, we know that the formula is negative P delta V. Ayun na yun. The P is the P external, Vf minus Vi. Yun na yun. Yung na-solve natin kanina. So ano itsura nun kapag nag-graph, no? Ang nangyayari dito is nagugulat na lang yung gas. Nandito siya nung una, nagulat siya, andun na siya agad, no? Sabi niya, andito ako. So, uy, andito na ako. Amazing. Gulat siya, no? So, if you want to determine the area under the curve, ito yon. Itong lahat ng iyan. Okay? Ang daming sobra, no? Yan. Okay. Kaya nga mapapansin nyo, kapag yung gas, pinipilit mo di ba kunwari may syringe ka, pinipilit mo siya i-compress. Ang hirap, di ba? Unlike kapag hayaan mo lang siya. Kasi, kapag yung gas sa cylinder, no, or let's say syringe, kapag pinush mo yon, ibig sabihin, may excess work kang ginagawa for an irreversible process. No? Pinupush mo siya, tinutulak mo siya. Kaya may resistance. No? May resistance. Sobrang work ang kailangan mo pa i-apply. Okay? Ganun yan sa syringe. No? Try nyo takpan. Tulak nyo yun. Sakit nun. Hirap nun. Okay? So, ganun yung idea ng irreversible compression. Okay? So, kailangan sobra-sobra yung ibibigay mong work. No? Kaya nakakapagod mag-compress. Kaya hayaan mo na lang siya mag-compress. Yan, kasi less effort. Kaya naman niya yun on its own. Okay? So for irreversible compression, ito yung equation natin. So P2 always ang basis natin for the pressure. And all the area under this curve is the work. Okay. So that's P2 delta V. So that's the area of this square. So the area of the square is length times width, no? So yan. How about reversible? Pag reversible, again, dahan-dahan, slow lang. Okay, slow lang, dahan-dahan lang. So this is P2, P1, V2, V1. So kapag dahan-dahan lang, lahat yan madadaanan niya. No? So infinitesimal decrease. So from here, dahan-dahan siya aakyat papunta doon. So lahat ng area na to madadaanan niya. So slowly but surely. Okay? So if kukunin natin yung area under this curve, ibig sabihin magka-calculus ulit tayo. Calculus. Basta may makita kayong infinitesimal, calculus yan. Gagamit tayo ng integral calculus. This time, positive na yung work, no? Kasi compression. So, what's the pressure again? The pressure is nRT over V. Ideal gas pa rin yan. Okay. nRT over V. Dahil yan sa assumption na ideal gas yan. Katulad pa rin ng kanina. Again, yung nRT constant yan. Then yung V, ito yung nagbabago. So that's 1 over V dV. Okay. If you integrate, that is still nRT over ln Vf over Vi. So that is the value of your work. Galing, ano? Pwede i-apply yung math. Actually, pag nag-study kayo ng thermodynamics talaga, either chemistry ka, physics, o kaya engineering, sandamukal na calculus ang lalabas. Okay. Ganun talaga. Okay. Ako, ang inaaral ko sa masters, pakita ko sa inyo para maloka kayo. Wait lang. Ito subset ko sa masters. Tingnan nyo. Chemistry ako, ha? Ayan o, chemistry, ha? Chemistry. Tingnan nyo mga pinagagawa ko. Derivatives. And ito. Integrals, di ba? Kailangan master mo talaga yan. Kasi kung hindi mo master yan, nga ka. Okay. So, ganun talaga. So, ang science, heavily dependent yan sa calculus. No? Ayan. Anyway, so yan, that's the work. No? Ang pinagkaiba lang sa reversible and irreversible compression and reversible expansion, positive sa compression, negative sa ayun, basta yun. Sa expansion. Okay. So yun sign lang yung nagkaiba din. Okay, so yun. Yan. Of the two, sino mas malaki? Sino mas ma-effort? Irreversible, reversible. Flip ko yung slides. Sino mas malaki ang value?
Irreversible po.
Irreversible. Kaya kapag mayroon kang kunwari, mayroon kang piston, hindi ko alam kung nakaka-experience kayo nun, pero ako dati kasi pag may minemekaniko sa sasakyan dati, nung may sasakyan pa kami, ayun, may piston yun. Tutulak mo, ang hirap. Pero pag hinayaan mo lang siya, kayang-kaya niya mag-isa. Ay, makapagod ka eh. Pag kinompress mo yung biglaan, sobrang effort kailangan mo ibigay, sobrang work kailangan mo gawin. Unlike kapag hayaan mo lang siya, smooth lang ang flow. Matagal nga lang. Pero at least hindi ka mag-e-effort masyado. Okay? And this is also a proof that work is indeed a path function. Kasi magkakaiba value niya depending on the process. Let's try that in application. Malapit na tayo matapos for our session today. And let's try this. 10 moles of hydrogen expand isothermally from 10 to 65 liters against a constant pressure of 2 atm at 25 degrees Celsius. Calculate the work done by the gas reversibly and irreversibly. Okay? Given. Ano mga given? Mole of gas is 10 mole. Volume, so initial is 10, final is 65. 10 liters, final is 65. And the constant pressure is 2 atm. So yung constant pressure yung gagamitin natin. Calculate for the work done by the gas. Nilagyan ko siya ng 2 kasi ito yung final pressure. Although constant yan, pero yan yung final pressure. Calculate for the work done by the gas reversibly and irreversibly. Number 1, reversible. Kapag reversible tayo, this is expansion. So the work is negative nRT ln Vf over Vi. So mole is 10 mole. R is the gas constant. Ang gas constant natin dalawa. 0.08206 LATM mole Kelvin. Ang isa pang R gas constant ay 8.314 joule per mole Kelvin. Same lang yan. Kinonvert lang yung LATM to joules. No? Gamit ka lang ng conversion na diniscuss natin last chapter. Okay. So, yun. So, I will call this the LATM. I will call this the RJ. The RJ is the gas constant in joule. So, I think gagamitin natin si RJ. Gas constant in joule. 8.314 joule mole Kelvin. Temperature, ano ba sabi? 298.15 Kelvin yan. Ln final volume 65, initial volume 10. Okay. Pindot sa calcu. Ang sagot ay minus 10. In kilojoules, the answer will be negative 46.40 kilojoules. Magka-cancel kasi yung mole, pati yung Kelvin. Ito naman magka-cancel yung liters. Ayan. So that's the irreversible work. How about the irreversible? So work here is negative P delta V. So the pressure is 2 atm. Volume is final minus initial. So that's 2 times 65 minus 10. 110. Yeah, 110, no? Negative 110 LATM. But this is not the desired unit, no? Kapag energy ang desired natin is joule. So we have to convert LATM to joule. How? Gamitin mo yung dalawang R constant, no? So yung RLATM sa baba, then yung RJ sa taas, no? To cancel the liter atmosphere. So ganun gagawin nyo dyan. LATM. So nasa taas yung 8314 joule mole Kelvin. Nasa baba yung 0.08206. Okay, then cancel the LATMs. Cancel yung mole Kelvin. So you're left with joule. Okay, so joule na lang yung natira. Okay. Pindot. 10, 110, 8314.08206. Answer is negative 11.14 kilojoules. Okay. Kilojoule na yung answer. Oops. Ay, hindi ko pala na-box. Kala ko na-box ko. Yan. Yan. So as you can see, the work is dependent on the process. No? So if that's reversible, ito yung value niya. If that's irreversible, this is the value. But still, both of them ended up with the final state. No? Ay, sabihin, yan. Work is path function. Okay. So I want you to screenshot that na lang. Okay. Screenshot. Then sulat nyo sa notes nyo. And then I will give you this problem. Okay. So for the next problem, I'm giving you 15 minutes. No? Medyo matagal to. Although mabilis lang to actually. Ano na lang, 10 minutes. Okay. So 10 minutes, kailangan masagutan nyo siya. And take note of the things that I emphasized earlier. Okay. Okay. So hopefully na screenshot nyo na. Answer this. This is open for 2 points. Tig-isa to. Kayo na bahala dyan. Pero didiscuss ko kung paano yan sagutan. Okay, 10 minutes. Okay, so I'll be back by 3:35 now. Okay. Yan lang talaga given dyan. So do everything you can para masolve yan. Okay? Medyo mahirap yan. Pero I will tell you how to answer this later. Okay? So yan. So 10 minutes now. Hirap, no? Hirap ba?
Hirap, sir. Hirap, sir. Di ko po alam paano sa sisimulan. Saan po yung given?
Hala, paano yan? Kunwari, ano na to? Midterm exam. Mamaya si Marvin may sagot ulit. Si JC may sagot. Ang iba tahimik kasi focus na sila talaga, no? Paano kaya yan? Sige. 35 na rin naman. So, ibig sabihin, wala makakapag-recite, no? Okay lang yan. Sa kabilang section, ganun din eh. Walang nakasagot. Sirat na. Wait lang. Ayan.
Wait, sir. Try po namin. Sure.
Bigay ko na sagot, no? Ito. So, ang hirap, no? Ganito, start tayo with the given. Okay, given. So, we have, ayusin ko sulat ko, given. So, initial volume would be 4 liters. Ibig sabihin, kailangan mo final volume. May sinabi? Wala. Wala. Nawawala final volume. Tapos, mapapansin mo, dalawa yung pressure na binigay. Di ba kanina isa lang? Paano kaya yun? So, ganito. Yung 15 atm, ito yung initial. So, sinabi nun, allowed to expand to a final pressure of 1 atm. Yan yung final. Okay? So, P initial is 15 atm. Final pressure is 1 atm. Mas ano pa yung mga kailangan? Pressure, volume, temperature, 298.15 Kelvin. Then, of course, yung R natin, yung dalawang R. Okay? So, yan. Ang problema natin yung VF eh. Paano kinukuha yung V? Meron akong sasabihin. Boyle's Law. Pwede niya to gamitin. Boyle's Law. Ang sabi sa Boyle's Law, P1, B1 equals P2, V2. Given yung P1, P2, given yung V1, hanapin mo yung V2. Di ba kaya? So yun, hahanapin natin yung VF kasi yun yung kailangan natin. So P1, V1 over P2 equals So this is 15 times 4 divided by 1. So this is 60 liters, no? So that's 60 liters. ATM liters. Nakuha na natin yung VF. Galing, 'di ba? Ano pa? 'Di ba kapag reversible, may mole na kailangan. Ibig sabihin, you should solve for the mole.
Yes, sir.
Paano kinukuha yung mole ng gas? Anyone? Paano kukunin yung mole ng gas? Para kunin ang mole ng gas, ang ginagamit ay ideal gas equation. Naalala nyo pa ba? PV equals nRT. Hanapin mo yung N. So, that's PV over RT. Ito yung possible na question sa atin. Ano yung gagamitin ko ng PV? Any of them. Pwedeng P1, V1, pwede naman P2, V2. Okay? So, kahit alin doon, P1, V1 o kaya P2, V2. But for convention, initial yung ginagamit always. So, initial pressure, 15 atm. Volume initial, 4 liters, R 0.08206 LATM. Mole Kelvin. Temperature is 298.15 Kelvin. Makukuha mo yung moles. Diba? O, Gen Chem yan, ha? So, kailangan maalala sila, ha? Ayan. 298.15 Kelvin. So, we have 2.45 moles.
2.45.
Diba? Galing, no? So, kailangan mo ng idea ng Gen Chem to answer this problem. Okay? So, sabihin, ang Gen Chem ay important talaga. So, ito sa gas laws to. Ito sa gas law lang din. Okay? So, yun, you can use other equations bukod sa mga binigay ko. No? And actually, yung ideal gas equation, hindi lang siya yung gas equation natin. Meron pa tayong real gas equation, may mga Berthelot equation. Ayun, so yung mga yon nakakaiyak yon. Okay. Pero okay na tayo sa ideal gas lang kasi introductory term lang naman tayo. Okay. So now we know all the variables we need. Then we can solve na now. Irreversible expansion, the formula is negative P delta V. Pero ano sabi kong volume, anong pressure gagamitin parate? Ano sabi ko? Yung final or yung external, 'di ba? Kasi final, at the final pressure, equal na yung forces. So, hindi nagagalaw yung takip ng piston. Okay, so yun. So, always the final pressure ang gagamitin or the external pressure. That is 1 atm times the delta V, 60 minus 4 liters. That will be negative 56 liter atm. Now, we need to convert the LATM to joules. Okay? How to convert that? Multiply it by the 8.314 joule per mole Kelvin. Sa baba, 0.08206 liter ATM per mole Kelvin. So you can see the moles, the liter ATM cancels out. The mole per Kelvin also cancels out. So you are left with the joule. Okay? So that's 56 times 8.314. Ayun. So the answer should be negative 5.67 kilojoules. That's the irreversible work. Diba? With the help of gas laws, we were able to answer the problem. So don't forget the gas laws parate, ha? Okay. Ayan, so how about letter B? Madali na lang to. Reversible. This is reversible, so W equals negative nRT ln Vf over Vi. So negative 10 mole, and urong ko na lang sa gilid. Kulang space ko dito. So W equals negative nRT ln Vf over Vi. That's negative 10 mole. R na gagamitin is yung naka-joule. Mole Kelvin. Temperature is 298.15 Kelvin. Ln final volume 60 liters, initial volume 4 liters. Plug them. Plug. Okay, yung mole magka-cancel, Kelvin magka-cancel. So, Ang sagot ay -10, 8314. The answer is negative 67.13 kilojoules. Galing, di ba? So, yun. And, katulad ng sinabi ko, yes po.
Yung negative 10 po, saan ko nang galing? Di ba po yung N po natin is 2.45?
Ay, 2.45 nga pala, sorry. Ako naman na mali. Thank you for that. Saan ko nakuha yung 10?
Yung kanina po. Yung kanina po. Kasi po yung 10 mole po yung sa kanina.
Ay, sa previous problem ba yan? Ay, oo nga, no. Sorry. Mamadali no. Kaya nagtaka ako. Ba't sabi ko, nagsasolve ako, sabi ko, ba't kaya parang iba yung nasusolve ko kanina? Kaya tinuloy-tuloy ko na lang. Ayan, so thank you. So this should be 2.45. 45 mole. Ayun, so thank you. Kaya nagtataka ako, sabi ko, ba't hindi ito yung nakuha ko kanina? May mali ba ako? May mali nga. 314,298.15 ln 60/4. Yun. Ito yung lumabas kanina, 16.45. Ayan ha. So, ayan. So, those are the answers na. Okay. So, again, consistent yung ating answer with the graphical, interpretation of the work. Sabi natin, if that is an expansion process, the work reversible is greater than the work irreversible now, because we are getting the area under the curve for the reversible work. Okay. Expansion yan. Okay, so ganun lang. No? About this one, this is good for 1 point. Okay. A gas expands against a vacuum. What is the work? For 1 point, answers in 3 minutes. In 2 minutes na lang. I mean 1 minute. 1 minute lang. Wala naman kayo solve eh. What is the work if the gas expands against the vacuum? Comment your answers. Ang sagot ay okay. May isa na tayong answer from JC. Ayan, dalawa na. Dali, comment kayo lahat para may points. Si Marvin naman, hinabol pa yung po. Okay. Lahat nagsabi, 0. Wala.
Pinagtiyawa ako.
0, 1, 0, to, 1, 2, 3, 4, 5, 6, 6. Ilan ba tayo? 7 tayo. Sino pwede nagko-comment? Si Noy. Ay, si Charlene. Nabol talaga yung po eh. Ang sagot ay 0. So, ibig sabihin, everyone gets 1 point. Ayan, teka lang, type ko. Ito yung tanong, bakit? Sige, tanungin ko kayo bakit. Ayan, may points na kayo, pero bakit? You can use your mic to share your ideas. Bakit kaya? Any idea bakit 0? Bukod sa sinabi ng Google 0. Ginugol nyo rin, no? Okay, ito yung sagot doon. Kasi, remember, ang ginagamit natin sa work is the final pressure or the P external. Diba ganito yung equation natin pag expansion. Ngayon, in a vacuum, what is the pressure of the vacuum ba? 0, no? So, at vacuum, pressure is 0. That means the final pressure is 0. And what is 0 times everything else? 0. Walang sagot, no? Walang work. Sabihin, walang work kapag expansion in a vacuum. Okay? So, ganun lang. What else, no? Ay, what else? Oops. Excited naman tong assignment na to. What else? Kunwari ako, tinulak ko yung pader. Is there a work?
Wala po.
Bakit wala?
Kasi pag di naman po gumalaw, di niyo po natulak yung pader.
Nagulat ka, gumalaw pader, no? Tawag ka ng engineer niyan. Kasi kapag yung pader hindi gumalaw, remember, ang work natin is negative F delta X. Pag yung pader di gumalaw, walang delta X yon. So, 0 yan. So, gaano pa man kalakas yung force mo, hanggat hindi gumagalaw yan, wala kang work. Okay? So, these are the special cases when our work is equal to 0. So, the work could be equal to 0 if that is an expansion against the vacuum, o kaya, hindi gumagalaw yung pader. There is no displacement. Try nyo tulak pader nyo mamaya. Try nyo para mapatunayan nyo kahit anong force gawin mo. 0 yan. Maliban na lang kung ikaw ay bulldozer. Ayan, bulldozer ka pala, no? Giba pa pader mo. So, doon lang magkakaroon ng work kasi gagalaw talaga pader mo nun. Pero if ikaw, tulak-tulak mo yan, walang work na. So, these are special cases where work is 0. Okay? So, as for your assignment, itong tatlo, puro irreversible to. Ganyan ba spelling ng irreversible? Yeah. Okay, so puro irreversible yan. So 1 to 3. Hindi pa ako nakakahanap ng reversible, pero I will give some more exercises pa. Ayan, ang dami nyo ng group assignment. Group assignment naman yun. So magtulungan kayo, no? Hindi yung isa lang gagawa. No? Pag isa lang gumawa, awayin natin. Sabihin nyo sa akin. Tapos itong 4 and 5, madali lang yan. That's delta U equation. Okay, so we are done with the work, no? So na-cover natin yung topic for First Law of Thermodynamics. Q ay to be continued ang Q. Okay? Kasi yung Q, we have to understand the next topic pa before we go there, the enthalpy. Okay? So stop muna tayo dito. So ito ay next meeting na lang. Dito natin makukuha yung Q of the reaction. Ayan, so medyo mahaba pa yan. Meron pang calorimetry, no? So, saka na yun. Okay, so we are done with our session for today. And again, balik ulit tayo sa calendar. On Saturday, let's give respect sa holiday. That is Labor Day. Ito yung araw ng mga nagtatrabaho pero walang sweldo. Okay, so yan. Yung mga ating mga magigiting na workers, especially the frontliners, no? So magbigay-pugay tayo sa kanila. So pahinga tayo. Okay, so yan. So wala tayong pasok this day. And ito sa Wednesday again, mag-asynchronous tayo. So i-discuss ko ito, pati ito doon sa asynchronous, no? Kasi ako ay may exam sa Lasal. Ay, medyo nakakatakot din eh. Kaya ayun. Dalawa yung subjects na may exam ako, kaya iiyak muna ako habang kayo nagpapakasaya. Okay, so ganun muna ha. Ako muna magdudusa next week kasi kayo bahala muna kayo mag-aral. Okay. So yun, again, ang prob set, ang deadline na to ay next week pa. Next week, May 8, no? Alam, May na agad. Oo nga, no? May na. May na agad. Okay, so yan. So, yan. Prob set lang ang required ipasa on this day. Group leader lang magpapasa. Then yung quiz ay kahit kailan kayo mag-take, okay lang. Wag lang magkopyahan. Malaki naman tiwala ko sa inyo eh. Wag niyo sirain. Okay. So, yung quiz, basta mag-take lang kayo, no? Like, even until finals, okay lang. Basta mag-take kayo. Pero, mas maganda kung before midterm makapagpasa na kayo ng quiz, no? 3 lang naman yung quiz natin eh. So, sana makapagpasa kayo ng quiz. Para mabigay ko midterm grade nyo. Okay? So, i-email ko yung grades nyo nito. Yun lang. Okay? So, again, with that, thank you for attending our session. So, again, kailan ulit tayo magkikita? Matagal-tagal. Dito na tayo magkikita. May 12. May 12 pa. Okay? So, ayan. So, ingat always and ingat always, gumamit ng face mask, face shield, and mag-ingat. Ayan, magkikita-kita pa tayo sa susunod na. Okay? Bye-bye and ingat. Upload ko to sa YouTube para may